All right, here we go with assignment B. It looks like just by looking at these first few problems that they're trying to introduce us and get us feeling comfortable with integrating side to side with respect to y. So again, that would be integrating the low to the high, or AKA the right minus the left. So reasons and things like that that you would do this is because when I'm trying to integrate, like going in a normal fashion, notice how no matter where I look on this picture, blue is always over the red. And so that's a great situation, and that's fantastic, and thus I would do that dx style. However, it doesn't work out so well when you're integrating against itself. Right? So if I'm trying to find the area of this thing, okay, it doesn't work out to do it this way because you can't subtract yourself. So you have to come up with a different method. And so instead of integrating that way, okay, what you have to do is you have to get, like, x is equal to, y squared plus 2y or something like that. Get things in versions of y and then integrate it dy, and that would be low to high, and AKA right minus the left. So this is way simpler to do it side to side. I mean, it's not impossible to do it up and down, but it would be a lot more work than what it's worth. It would be a lot more work than what it's worth. So for instance, if I were to integrate this up and down, what I would do is I'd cut it right here, I'd integrate that portion. Then to integrate this portion, I would have to, in essence, split this in half, find the integral of that top, and then I could find the integral of the bottom, or I could just multiply the top by 2. But again, that's a lot more work. The easiest way is to do it, right to left, from low to high in this situation. All right, now let's pretend like we don't see that where these intersections are. Like, where is this y coordinate of the low, and where is it? So I need to know where to integrate from this low to high. And so what I do in this situation, since these are both equal to x, is you can set them equal to each other. They will tell you the y coordinates. So here, I'm going to add to the right, and so this will be a positive y and a negative 6. Going to a 1, that would be a negative 2 and a positive 3, which would be a positive 2 and a negative 3. And so I see that this y coordinate is positive 2, this y coordinate is negative 3. So again, when you need to find those things and you can't use your calculator or something, you can just set the equations equal to each other as long as they're equal to the same thing, like x is equal to x. Okay, on with this. Okay, I'm just going to do this with respect to y because it's going to be simpler. I swear to you, it's going to be simpler in this situation. Again, not in every situation, but in this situation, heck yeah, it is. All right, so integrating. This is going to go from negative 3 to positive 2. Of the right, which is the parabola, that's the 4 minus the y squared, minus the line, which is y minus 2. All right, so this is negative y squared minus y plus 6. So this is negative 1/3 y to the third minus 1/2 y squared plus 6y. Going from negative 3 to positive 2. So fire up the old calculator here, and let's go ahead and plug in the 2 minus the negative 3. So the 2 is negative 1/3 x to the third minus 1/2 x squared plus 6x. 22 thirds minus the -3 answers, a -3, second enter, second enter, second enter, -27 halves. So this is 22 thirds minus that. Hope that's right. Can't guarantee it, but I'm pretty sure. So that's that. And again, it's going to be way easier because otherwise we would have to, as I said, integrate from, I think that's what, -5 to 0. -5 to 0, so that would be this chunk of it. And then I would integrate from 0 to 4 of the positive square root version of this. That would be the positive square root of 4 minus x, which again, it's just nasty in its own right. And then I have to double that. So take care of it in one easy equation in this case. All right. Sketch the region. Okay, so parabolas, when it's a positive x squared, it opens in the positive direction. So similar with the y, it's going to open in the positive x direction. And then, okay, you can think of this as x if you're really, like, so I'm very used to y being equal to. And so what this would be is y would be equal to x minus 2. So that helps me kind of get the idea of what the picture looks like. And then from there, I can go ahead and do all the work and find all the intersections and things like that. So here, this is x, so y squared is equal to y plus 2. And all I'm just trying to find is where are the bounds, where am I integrating to and from? Because again, I'm going to do this side to side. And again, the big would be the line, the small would be the parabola because it's right minus the left. Anywho, I digress. So this is y squared minus y minus 2 plus 1 minus 2. That is -1 and positive 2. That'll go away in just okay, so the integration in this case is going from -1 to positive 2 of the line minus the parabola so I could reorganize the order of this, it doesn't really matter. So this is just 1/2 y squared plus 2y minus 1/3 y to the third. And the roll from -1 to positive 2. And so this is 1/2 x squared plus 2x minus 1/3 x to the third. It's 10 thirds minus the -1 answer. -7/6. This is 10 thirds minus that. Okay, y squared plus 1. So this would have a kind of like a y-intercept of +1. In this case, it's an x-intercept of positive 1. X is equal to 0. Y is equal to negative 1. Y is equal to positive 2. So this is our bound. Again, right minus the left, and this one's going to the axes, so this is good to go. All I have to do is integrate from what, negative 1 to positive 2 of the parabola minus nothing. Again, this would be way, way, way harder if you were to do it up and down style. Way harder. So this is the integral from negative 1 to 2 of the parabola. And going to the axes, so I don't have to subtract anything. So this is y to the third, 1/3, y in the world from negative 1 to positive 2. And then negative 1. (18/3), this is 6. Okay, it looks like we're kind of getting back into the x's a little bit. We'll see. We'll just see how the picture turns out, and then we'll make some decisions from there. So we graph, and the rest are lines. So, yep, I get it. So let's just kind of determine how this is going to look. So we have this, we have this. What are our other boundaries? We have an x is 0. We have a y of 2. And we have a y of 10. This is actually our boundary. Now you could do that up and down, but again, that'd be kind of silly to do it up and down because you would have to separate it because you don't have a distinct top and bottom everywhere along the route. Here I do have a distinct top and bottom, or right and left, I should say, from 2 to 10. It's always the curve minus the axes. And so right now I have y is equal to 10 divided by x, but just a little bit of manipulation, swippy swappy, x is equal to 10 divided by y, same difference. So now I have an equation of this, and now I can just integrate it from 2 to 10, getting that same area, as opposed to integrating from 0 to whatever the heck that intersection point is, question mark, and then from question mark to second question mark. I don't know what those things are. Maybe 5 and 1, 1 and 5. So you could integrate from 0 to 1 and 1 to 5. But again, it's kind of silly. I'm just trying to take care of it all in one move. Okay, so this is going to be our integral from 2 to 10 of our curve, which is 10 divided by y, or aka 10 y negative 1. Okay, so this is ln. And so this is going to be 10 ln of 10 minus ln of 2. A subtraction of ln's is a division on the inside. So what I'm saying is this. This is 10 of ln of 10 divided by 2 And so this is 10 ln of 5. Okay. Not the greatest at trig, so I'll just kind of use my calculator. Let's try this again. So we got 2 sine x, and we have a tangent of x, and this is kind of in the world of negative pi over 3, so I'm going to go to my window. My lower x limit is negative pi over 3, so I'm going to give it a little bit more. I'm going to say minus 0.2 or something like that. And then the upper bound is pi over 3, and again, I'm going to give it a little bit of extra room. I'll say plus 0.2. I know signs are, the top is 1, the bottom is -1. However, with the 2, the top is 2, and the bottom is -2. So I'll go to -2.5 to +2.5. Which should probably give us a decent picture. There's our sine. There is our tangent. So we first had our sine, which is this dilly. And then we had our tangent. Let me find this. This is our sine. Well, I think I had it backwards. I'm sorry. Yeah, I should have known better. All right, so our sine is that thick line that does this. And then our tangent is the thin line that does this. This is technically an odd function, so all I'm going to do is I'm going to find the area of 1 and then just double it. Where does this intersection occur? I'm very much assuming that it's going to be pi over 3. Let me just show you how I test it. I find the intersection. So I take my cursor kind of closer to that intersection so it doesn't come to 0, 0. And the x is 1.047, et cetera, et cetera. Okay, that's what it's telling me that x intersection is. Now, I don't want to use that. It probably has a smarter version. So I'm just going to check out what the heck is pi over 3, because they gave it to me for a reason. And what do you know? It's the same gosh darn thing. So this upper limit is pi over 3. So I have 0 to pi over 3 of this. And so I don't need to do it side to side. I'll do it up and down. And this will be the sine over the tangent. So from 0 to pi over 3 of the sine over the tangent. Okay, sine is negative cosine. Tangent is oh, this is one that yeah. This is where I have to use some of the things from the front of the book. I don't know what the integral of tangent is like, and I don't expect you to either. Yeah, the integral of tangent is something freaking weird. So it is negative ln of what was I looking for? Negative ln of absolute value of cosine u. In this case, that's x. Yeah, I don't expect you guys to know that one. That's in the front of the book kind of stuff. Okay, 0 to pi over 3. All right, so this minus is going to be a plus. All right, So let's get some of these things. We need to know about pi over 3, which has coordinates of 1/2 square root of 3 over 2. And we need to know also about 0, which is 1, 0. All right, so the first one is the pi over 3. So minus 2 cosine. Cosine is 1/2 plus ln of cosine. Again, that's 1/2. Minus 0, so that's negative 2 times 1. Boo. And again, that's going to be 1, so plus ln of 1, which is 0. That's going to be 0. ln is 1, 0. Okay, so as I was saying, ln of 1 is equal to 0, so I don't have to worry about that portion of this. And so this is going to be, what, negative 1 plus 2. This is going to be 1, negative 1 plus 2 coming from the other side. Negative 1 plus 2. And then we have the ln of 1/2, which again, they probably, this is probably what they do. So this is the same thing as saying ln of 2 to the negative 1. And then when you have these exponents, they can come up front. So this is the same thing as saying negative 1 ln of 2 right here. So how they are probably going to make this answer look, they'll probably say this is 1 minus ln of 2. All right, here's probably some u substitution. Yeah, most likely some u substitution here. So let's take just a gander at what this picture looks like. So 1 divided by x squared. Then we have e to the 1 divided by x. Window was too small. Let's go with negative 0.2 to 3.2 to 5. Okay. So in the world that we're interested in, this swoops down, and we are doing that with y is equal to 0 from x of 1 to x of 3. All right, so this is 1 and 3, so I know those boundaries, that's pretty decent. And so I just have to integrate that from 1 to 3. This is most likely going to involve u substitution. Okay, so we're not equipped to do that just yet. So here we go. U in this situation is x to the negative 1. So du is negative 1x to the negative 2 dx. So that exists except for this negative 1. So I need to undo that with another negative 1. Because this is u substitution with limits, let's reevaluate those limits. 3 going into that is 1/3. 1 going into the u again is still 1. Okay, so updating my integral here, this is going to be negative 1 of 1 to 1/3 of x squared goes away. This is e to the u and u. e to the u is e to the u. And again, this is from 1 to 1/3, -1. I'm not going to really worry about this answer too much. This would be the third root of e plus e, something like that. It's something of that nature. Minus e. So something like that. Again, I'm not going to sweat it too much. You can find the decimal answer if you desperately need it, or you can manipulate that answer if they do give you a multiple choice solution. Long story short, that's correct. I'll guarantee it. All right. Find A such that divides the region into two equal regions of equal area. Okay, so let's first find the area. What the heck are we talking about here? All right, so here we have a y is equal to x, a y is equal to 4, and an x is equal to 0. So this is the area that we are speaking of. Okay, and so we want to talk about x's, like I would most likely do this with y's, but we need to talk about x's here. Now, notice what the top equation is. It's 4. 4 is the top. The bottom equation is our line. All right, so to figure out this initial area, we are going to, this is at the point 4, 4. So this has an x coordinate of 4, so we're going from 0 to 4. 0 to 4 of the top, which is 4, minus the bottom, which is the line. All right, so you have to take that kind of into consideration. And so this is the area right here. And so this is what, 4x minus 1/2 x squared from 0 to 4. All right, so this area is going to be 4x minus 1/2 x squared. 8. Okay, now, so what we need to do now is we need to come up with some value of a, that is an x value, that divides this area in half. Okay, so what they're asking us to do is this. We need to come up with some a value that when I integrate, it's splitting this area in half. So I'm going to focus in on this left area. So I set up an integral, okay? I set up an integral that looks something like this. My integration, my area is going to start at 0 and is going to go to the letter a. And it's going to be of the same thing, 4 minus x. Okay? Now, this is going to give me this area to whatever this mysterious a is, and I need that area to be half of what the area is. So I need this area to be equal to 4. Right, so we still integrate 4x minus 1/2 x squared, et cetera, et cetera, et cetera. And this is going from 0 to a. Substituting in, this is 4a minus 1/2 a squared minus 0, and that's equal to 4. I don't know if this turns out to be anything nice. So I'm going to multiply by 2, and I'm going to move this stuff to the right. So this is going to be a squared minus 8a is plus 8. So what I did right there Then multiply both sides by 2. We do the same thing to both sides, it's all good. Multiply both sides by 2, and then I moved all this stuff over there so I can potentially factor, which I can't. I can't factor this. So I'll do the completion of squares. Give myself a little bit more room. What I'm doing is I'm solving for A. All right, so I'm thinking of this as it being on the right-hand side. So this is a squared minus 8a, and then I move the constant across, negative 8. Okay, then I have to take half of that middle, half squared, and then I multiply back. I have to add that half, whatever that half is, squared. Again, this is the completion of squares. So this is 8. Now I just solve. So A is equal to positive 4 plus minus the square root of 8, which is 2 root 2. Okay. So I could have two potential answers. I could have 4 plus 2 root 2. But there's a problem with that. That is not on the interval from 0 to 4 where I need my A to be. So it's not the plus version. So 4 minus 2 root 2 is 1.7. Huzzah, there, that's exactly what it is. So A is equal to 4 minus 2 root 2, which is AKA 1.6, basically 1.17. 1716. Okay, find the area of the figure of the shaded region. So we have this negative parabola in this line. So I need to know where this integration starts and stops. That's what I first need to know. So that would mean 2 minus 4x minus x squared is equal to negative 2x minus 1. So x squared plus 4x is positive 2x, minus 2 is minus 3. So this is x minus 2 plus 3. So this occurs at positive 1 and negative 3. All right, so I know now where my integration starts and stops. Now all I have to do is actually integrate. So my integral is going to be from negative 3 to positive 1 of the parabola, which is the one with the x squared. So that's the 2 minus 4x minus x squared. And I'm going to subtract the line, which is negative 2x minus 1. Okay, so let's clean this up just real quick. So this is negative x squared plus 2x. So that would be minus 2x plus 1. And so that would be a positive 3. Okay, so here we go. Negative 1/3 x to the third minus x squared plus 3x in the universe from negative 3 to 1. We plug and chug with the 1. That's negative 1/3 x to the third minus x squared plus 3x. 5/3. Minus the same idea with negative 3. Negative 9. And so we have 5/3 minus that. Whatever this is, 32/3.